Hi everyone. Today we are going to discuss about Bayermore algorithm. So we know already what you mean by string matching algorithm. String matching problem in which given some text like this, a large number of characters, and given some pattern. We need to find whether the given pattern is present in the given text or not. So this already we solved, this string matching problem we already solved by using two methods. So the first one is by applying brute force technique. So in brute force technique, what we did, we align the pattern against the text from the beginning, and we start comparing the first character. The first character match, we will check the next character. Whenever the mismatch occurred, we shifted the pattern towards its right by just by one position. So like this, whenever the mismatch occurs, we shifting the pattern by only one position till we find the pattern or we will reach the end of the text. This is what we done in the brute force string matching algorithm. But this is very inefficient method as it makes many unnecessary shifting. Every time it is shifting by one. Okay, so most number of shifting is being done. So it is time consuming. So to overcome that disadvantage, we go for one more method called Horspool algorithm. The Horspool algorithm avoids that unnecessary shifting the pattern. Okay, so that means it will shift the pattern towards its right as long as possible. Okay, by constructing one table called shift table. Okay, so now let us apply that Horspool algorithm to this problem. So we know that Horspool algorithm, we are not yet started Bayermore, so still I'm in Horspool algorithm. Horspool algorithm construct one table called what? Shift table, right? Called shift table that I constructed for possible characters of the pattern. So in the pattern, what is there? B, A, that means this pattern and so only three characters. One is A, B, O, remaining are repeated. So A, B, O, maybe it may consider other characters. So other characters. Okay, now you find out this character is at what distance to the last character. Now, always take the last occurrence. This A is the first occurrence. Last occurrence is this one. This is at a distance 1. This is at a distance 1. So A value is 1. Similarly, now check next value is B. You check B value is what distance C. B is the first occurrence. This is the last occurrence. Don't check this one. This is leave this. Only the remaining characters we need to check. Okay, B. B is at a distance what? 1. Okay, this is last occurrence. This is at 1 and this is at a 2. So B is at a distance 2. And O. O is at a distance simple. This is O 1, 2, 3. So 3. Remaining characters pattern length. What is the pattern length? 1, 2, 3, 4, 5, 6. Pattern length is 6. This is what the shift table constructed by the what? Horspool algorithm. Now, I will use this concept to find whether the given string is present or not. Okay. So, now again, what is the procedure? Align the given pattern against the text from the beginning. But in brute force, we started comparing from the beginning. But now here we have started comparing from the last character. Now in the last character, I will check. These two character matches, no mismatch occur at the first position. When the mismatch occurs at the first position itself, now take the value of the mismatch character of the text. Here, which is the text? These are two characters we compared. One is K and another is B. This is the text character of pattern. This is the character of the text. Now shift value of the character of the text. So K value is what? So it comes in other characters. So K value is 6. Now shift the pattern towards its right by 6 position. So 1, 2, 3, 4, 5, 6. So 6. Now I shifted the pattern here. B, A, O, B, A, B. So now again. So now I compare these two matches. These next I come from the last. These two matches. I compare these two. Here mismatch occurs. Now again, when the mismatch occurs, check whether the mismatch character occurs in the remaining characters. No. If it is not present, shift the pattern towards its right by its length. What is the pattern length? 6. So again, I am shifting the pattern length 1, 2, 3, 4, 5, 6. So B, A, O, B, A, B. Now again, I am comparing these two characters and again mismatch across the first position itself. When the mismatch occurs at the first position, check whether the mismatch character of the text, this is the text mismatch character, this present in the remaining characters, is present in the remaining characters, yes, it is present. So now A is present in the remaining characters of this pattern. So what is the value of A? Take from the shift table. So A value is what? 1. So shift the pattern towards its right by one position. So only one position, B, A, O, B, A, B. Now, again, you check this one. From the last we are comparing. Now again mismatch at the first position. So in the first position, O. Now O is at what? Now O is present at the remaining character of the take pattern. Yes, O is present at the remaining characters. Now what is the shift value of O? 3. Now shift the pattern by 3 positions. So now 1, 2, 3. So B, A, O, B, A, B. I shifted. Now you start comparing this character from the last. So okay, B matches, A matches, B matches, O matches, A matches, B matches. So all 6 characters has been matched. So that means now we found the pattern at here. So we found. So here, how many shifts we did actually? How many shifts we did? This is initially we aligned. From here to here we shifted 1 time. Here to here we shifted 2nd time. Here to here we shifted 3rd time. Here to here shifted 4 times. That means using Horspool algorithm, we shifted how many times? 4 times we shifted. And how many comparisons we did? See, check 1, 2, 3, 4, 5, 6, and this green color 6. So totally 12 comparisons. So 12 comparison we did. Using what? Using Horspool algorithm. So now let us apply Boyer-Moore algorithm to this one. Let us see how many shifts we do and how many number of comparisons it will do. Okay. So now, before going into the Boyer-Moore algorithm, what is the disadvantages of Horspool algorithm? See, this Boyer-Moore algorithm also uses the same table, but Boyer-Moore algorithm call this table as a what? Bad symbol table. Same shift table. Here we will call it as bad symbol table. See, again I am repeating, Boyer-Moore algorithm uses same shift table generated by the Horspool algorithm, but it will call this as a bad symbol table. Why it is called bad symbol table? Let us see that one. Okay. So let us take this example, case 1. Assume this is the text and this is the pattern. Now for this pattern, so now I am considering the shift table of Horspool algorithm. So now this pattern consists of only 3 characters A, B, C, remaining characters are false others. Okay, now what is the distance, see, from to the last character? A is at what distance? A is at distance 1. So shift value of A is 1. What is the shift value of C? Now C is the last occurrence. C value is at a distance 1, 2. So C value 2. What is the B value? B is a distance 1, 2, 3. So B is at a distance 3. Others are pattern size. Pattern size is 5. This is the shift value. Okay. So now let us apply the same Horspool algorithm. So now I start comparing the last character. First to match itself, mismatch. Now check whether the mismatch character present in the remaining characters. Yes, it is present in the remaining character A. Take the value from the shift table. A value is 1. So shift the pattern towards it by one position. So I shift the pattern towards it right by one position. So A, B, C, A, B. So now again start comparing from the last one. So I compare this successful. I compare this. Okay, successful. Now here mismatch occurs. The third character. So now, but before mismatch occurs, 2 character has been matched. So what is the shift value? What we need to do actually? Shift value minus number of characters is matched. Let us take K. K indicates number of matched characters. Number of matched characters. Now, what is the shift value of A? 1. shift value is 1 minus number of matched characters. How much? 1 is matched, 2 is matched, 2. 1 minus 2. Shift by this. 1 minus 2 how much? Minus 1. That means what? Shift the pattern towards its right by minus 1 position. How to shift? It is not at all possible to shift. Okay, that is the problem. Okay, that is the problem with shift table constructed by the. Sometimes what happens? See, sometimes if the shift value of A is 2, assume shift value of A is 2, but 2 character has been matched, but 2 minus 2 what? 0. Shift the pattern towards it by 0 position. That doesn't have meaning. So that is the problem with the shift table generated by the Horspool algorithm. That's why this shift table is called bad symbol table by this Bayer-Moore algorithm. So Bayer-Moore algorithm called this shift table as a bad symbol table because of this reason. Sometimes we will get the value minus or 0. In that case, what Bayer-Moore will suggest, now it will say you shift the pattern either maximum of, that means now this distance it will call as a distance 1 t1. Distance 1 is equal to maximum of whatever the shift value, you will get shift value minus number of matched characters comma 1. So whichever maximum, suppose if I in the previous day I got some minus 1 or 0, if this becomes minus 1 or 0, this is 1. So whichever it is maximum, that time I am taking as a D1 as a shift table. Okay, this is the slight change what Bayer-Moore algorithm will do with the shift table generated by the Horspool algorithm. Hope it is clear. So now along with this table, so this Bayer-Moore algorithm also generates one more table called good suffix table. Okay, so let us see what do you mean by that good suffix table. See, this I am retaining because this is the 4 number of times we shifted and 12 number of comparison we did by using Horspool algorithm. Okay, so this is the same thing. Now we will apply what? We will apply Bayer-Moore algorithm. But Bayer-Moore algorithm, along with this, it uses one more table called good suffix table. What do you mean by this good suffix table? So now this is done at one level. So now second table, that is for the distance 2. So now it will generate good suffix table. Now, what we are doing here we are checking only character by character. See, this Bayer-Moore algorithm is exactly same as Horspool algorithm, only in the case if the mismatch occurs at the first position. Suppose if it occurs at the after successful comparison, now it will find out whether it has to move distance either by the D1, that is bad symbol table, or with the D2, there is a good suffix table. So this I will call it as a D2. This distance is called D2. Which one? So that it will find out. Now it will find out after a few successful comparisons. So that's what the suffix will call. For example, let us take this example. A, B, C, A, B. Now this is my what? One pattern. So now, wait. Okay, now my pattern. Okay, K value, that means number of matched characters. K, number of matched characters, K, and the shift value D2. So now, what is the pattern size I took? A, B, C, A, B. Right, this is. Now, if the number of characters has been matched is only 1, so that means if only one character has been matched, that means the last character, since we are starting from the last character has been matched. So now you check whether that character is present in the remaining characters. Yes, it is present here. Now you check what is the distance. Now this is at a distance 1, 2, 3. Now the distance of this is, distance 2 is 3. Now similarly, now you check. Now the same pattern I will check. Now A, B, C, A, B. Now number of matched characters are 2. If the 2 characters has been matched, that means if it is 2 character has been matched, check whether AB is there somewhere else. Yes, it is there, AB here. Now you check, this is called suffix. No, don't compare to only one character as in what Horspool algorithm. Now you check the number of matched characters. That's what I call suffix. Number of characters, two. Two characters has been matched. Two characters AB. You check with the same occurrence it is there. Yes, it is there. Now this AB is at what distance to the last character? AB is at last character. So now this AB is at distance 1, 2, 3 again. So that means now distance of this one for this is also 3 in this example. Okay, in this example. Now let us take one more. Okay, A, B, C, A, B. Now 3 characters. Now if suppose 3 character has been matched and after that mismatch occurs. Now that means C, A, B. So this is a match. So you check CAB. CAB is there? No. But so that means this all 3 characters are not there. But out of these 3, 2 characters there. So that only you check. Now again this is a distance 1, 2, 3. So this is also 3. For this example, this is the good suffix table. Okay. So now let us see one more example. Now let us take one more example how to construct good suffix table. Okay. Now you take A, B, C, A, B I took. Now you take A, B, C, B, A, B I will take. Okay. So now here, if the number of matched characters is 1, that means one character is matched and then mismatch occurs, means this one character is matched and then one here mismatch occurs. Now you check whether this B is present in the remaining. Yes, it is there. So it is there where? It is there here only. The last occurrence. Correct? This is there in the here only. Now you check. This B is at what distance to the last character? 1, 2. So distance is 2. Now you take for the next possibility. A, B, C, B, A, B. Now if the 2 character has been matched, that means 2 character has been matched and then what? Mismatch occurs at this position. Now you check for AB is there. See, this is CB. Okay, now AB is there here. Now this AB is here. Now you check. He is at a distance what? He is at a distance 1, 2, 3, 4. To the last character you need to check. Okay, it is a distance 4. So distance is 4. Now check for the next value. A, B, C, B, A, B. Now again, is the 3 character has been matched and then mismatch occurs. That means these 3 character has been matched and then mismatch occurs. Now, but BAB is not there, but AB is there. I don't know. Before that, see, this is the pattern, but the test, so many characters are there. Before that, it may have any number of characters, but AB is present. So I am taking this 2 only again. So now again, this is also the distance what? 1, 2, 3, 4. So for this also 4. So now you check for the last one. A, B, C, B, A, B. So now if the 4 character has been matched, that means if the 4 character has been matched and then mismatch occurs at the 5th one. So now again CBAB is not there, but I don't know before this whatever it may have. So I will check this one only. Again it is also distance 4. So this is the good suffix table for this example. So I have given 2 examples how to construct what? Good suffix table. This is the good suffix table. So distance 2 I will get from the good suffix table. So 1 example, 2 example. Hope it is understood. Now let us see how to apply for the same problem Bayer-Moore algorithm. For that we need to construct one more table for this given pattern. For that is a good suffix table. Now for the good suffix table for this example, this is the pattern. Now if the K indicates what? Number of matched characters. The number of matched character is 1. Okay, so now that means what? If the number of characters match is 1 and then mismatch occurs. Now you check whether this number of characters is there or that. Number of characters, that is suffix. Yes, is here. So what is the distance? What is the distance it is there? So it is at the distance how much? 1 and 2. So distance is at 2. Okay, next. Now check for the 2 character. If the 2 character has been matched, so that means what? This 2 character has been matched and then mismatch occurs. So the check for these 2 complete as it is. Okay, this number of suffix. AB is there, no AB, but there is only B is there. I don't know. Before that, it maybe A is there. Maybe, I don't know. Okay, B is there. Now, you check what is the distance from here. So now from this one, 1, 2, 3, 4, 5. So distance, this is 5. Similarly, you check. Now, three characters. If the three characters have been matched, so that means these three characters have been matched. BAB is there in the remaining. BAB is not there. That last B is there. So B is there. So I will check. Because before this, it may be there. We don't know what it may be. Okay, so it is there. Again, the distance is what? 5 only. 1, 2, 3, 4, 5. So this is again 5 only. Next again for 4. So that means the 4 character has been matched. Okay, O, B, A, B, not there, but only among this one character is there. That's the last one is B. We cannot take this. This we can take. Before this, it may be O, B, or something, whatever. I don't know. Okay, so it may be there. So again, this is a distance 5. Same thing. 1, 2, 3, 4, 5. Similarly, if there are 5 character has been matched and then mismatch occurs, again this B is there. So for this also 5. So this is the good suffix table for what? Bayer-Moore algorithm. So Bayer-Moore algorithm uses the two table. First one is the shift table generated by the Horspool algorithm. That itself is called as a bad symbol table and good suffix table. Hope you people clear this. Now we will see how to apply this one. So now the final formula what this Bayer-Moore algorithm is used, this one. That means whenever the mismatch occurs in brute force string matching, what we are doing, simply blindly we are shifting the pattern towards its right by one position. So how we are, by what distance, that is by what distance D, we are shifting the pattern towards its right in case of Horspool algorithm from the shift table value, by this value. So now how much we need to shift the pattern towards its right by how much distance in Bayer-Moore algorithm by this formula. Shift the pattern by this distance D. When if k is equal to 0, if number of matched character is 0, that means we are not match any character but mismatch occur at the first position only. First position only. So then what? Then use D1. What is the formula of D1? This is the D1. D1 is equal to maximum of whatever the shift value of this bar symbol table minus the number of characters in case 0 by 1. So whichever it is, that you can use. That is a D1. Okay, that means directly you take from the shift table. Not a problem. Okay, next. If k is greater than 0, k is greater than 0 means number of, that means if some number of character has been matched, like this, one character has matched, 2 character has been matched, 3 character has been matched, then after some number of character has been matched and then mismatch occurs, at that time use this formula. At that time you calculate both D1 and D2. D1 I will get from this bar symbol table, D2 I will get from this good suffix table. Whichever it is maximum, that you use. That is the distance. So this is the formula what you need to remember. Okay, now let us apply this one. Okay, now initially same thing, fine. We started comparing from the first character or last character. Now mismatch occurs at the first position itself. That means which one? K is equal to 0. That means we have not matched any of the characters. So that means mismatch the first occurrence. No character has been matched. At that time what you have to do? Use D1. D1 is what? Check the shift value of K. K is false in others. So it is not there. So shift the pattern towards its right by pattern length. What is the pattern length? 6. Shift by 6 positions. Okay. 6 B A O B A B. Now I shifted here. So now see, this is the first case. In the first case I shifted by D1. Now here when I started comparing, so first characters matched, next character has been matched. Now a third character mismatch occurs. This is underscore. This is here mismatch occurs at the third character. That means after two successful comparisons, third position we failed to match. That means see, after 2 comparisons, k is equal to 2, number of characters has been matched 2, then we got this one. Okay, at that time this is a D2 value, but we have to take which is D1 D2 maximum. So now you see this is the second one. In the second one I am writing here. Now we know, check D1. D1 is what? Check this one, maximum of, so D1 is equal to maximum of shift value. Shift value of mismatch character. Which is the mismatch character? Underscore shift value is what? 6 minus how many characters has matched? K value is what? 2 characters matched. 6 minus 2 comma 1, so 4 comma 1. So this is what? 4. D1 I got 4. Maximum is 4. So now you find D2 also, because when K is greater than 0, I have to use this formula. D1 I calculated, D2 you calculate. D2 is what? D2 for K is equal to 2. K is equal to 2, D2 is what? 5. So D2 also no. Now D is equal to maximum of D1, that is 4, D2, that is 5, which is maximum 5. So you shift the pattern by 5 positions. Okay, that's what it says. Now I am shifting by 5 positions. Okay, 1, 2, 3, 4, 5. So now my thing comes at this position, pattern comes this position. So now again start comparing from the last character. BB successful. Next again I got mismatch. Now I got mismatch at the what? Second position. After how many successful comparisons? After one successful comparison, I got the mismatch. So now again I need to find K is greater than 0 now. One cat has been matched now. So I need to use this formula. So that means again for the third one. Okay, for the third one, this is the third one. So now third one I am writing now here. See the third one. So now D1 is equal to maximum of what? Shift value. Shift value of underscore is what? 6 minus how many characters has been matched? K is equal to 1, comma 1. How much? 5. D1 I got 5. Now D2 is how much? How many characters has been matched in this case? One character has matched, second mismatch. One character has matched. 1. K, when K is equal to 1, what is the value? 2. So D2 is equal to 2, which is maximum. So now D is equal to maximum of D1 comma D2. D1 is what? 5. D2 is equal to 5, which is maximum. 5 is maximum. So we are shifting by 5. Now again shift the pattern by 5. So now if I shift the pattern by 5 positions, 1, 2, 3, 4, 5. So now my pattern comes here. B, A, O, B, A, B. So now here I matched BB matches, A matches, B matches, O matches, A matches, B matches, all matches. So I found the pattern here. So this is Bible algorithm. Now here, how many shifts we did? If you observe how many shifts we did from here, this is initially we aligned 1, then 2, then 3. Only 3 times we shifted. But by applying Horspool, we shifted 4 times. But we shifted only 3. That means Horspool algorithm is also making some unnecessary shifting. That also we eliminated by applying what? Bayer-Moore algorithm. This is the beauty of the Bayer-Moore algorithm. Okay. So hope you people understood Bayer-Moore. Okay. Summary is Bayer-Moore algorithm is the advanced version of Horspool algorithm, or we can say Horspool algorithm is a simplified version of Bayer-Moore algorithm. And Bayer-Moore algorithm works exactly same as Horspool algorithm if the mismatch occurs at the first position itself. That is when K is equal to 0, simply take from D1. But if the mismatch occurs and after few successful comparisons, then I have to use this formula. Okay, maximum D1, D2. D1 I will get obtained from the shift table generated with the Horspool algorithm. Same thing, it is called as a bad symbol table, and D2 is the good suffix table. This is the example. Hope you people understood the concept. Okay. If anybody having any questions, please write it in the comments. Thank you. Thanks for watching.